Hey guys, and welcome back. So in the previous nugget, we had talked about sys v init, and we also mentioned the concept of run levels. Now what I want to talk about is a very particular file, and this is called the inittab file. And the location of this file is something you want to be remembering. And this is going to be located in the etc directory. So etc inittab, this is where we want to go. Now, in order for a system to know which run level it should be running at, so to speak, the actual init process, remember that one we talked about, the very first process, process number 1, init is going to check in this file, like I say, within etc inittab, and it's going to read the contents of this file and infer what indeed the run level should be. So what I'm going to do is to briefly show you what this file actually looks like, and then we'll talk about what the contents actually mean. Now here is the thing, with respect to sys v init, this is actually an older style of managing your system. In more modern systems, we have something called systemd, but for the purposes of the examination, we have to know sys v init. But what I'm trying to say here is that it happens to be antiquated, and I do not actually have this configuration file on my distribution right here. If I happen to go into my etc directory and I do an ls, you will see that on this newer system, this file doesn't actually exist. If I grep for init, we can see init.d, but we cannot see inittab. So what I'm going to do is to try to find an online example for you to view, and then we'll talk about what the contents actually mean then, shall we? So let me go and find an example. Okay, so this is an example of what an inittab file would have looked like. Okay, so let's focus in on this part right here. Now, this is actually subdivided into 4 different sections. These are separated by colons. So at the very left-hand side here, we can see LO, L1. In fact, let me just make my pen a little bit narrower. So this is the first value here on the very left-hand side. This value is known as the ID. Now, the ID is just a way for you to refer to a line. It doesn't actually have any type of effect. We just want this to be a unique value, okay? So that is the first value. Then we have our colon, and then we go to our next value, value number 2. So in this case, we see 0, 1, 2, 3, 4, 5, and 6. These actually correlate to the run levels what we're talking about. And now the third column here, see the word wait for every single one, but it doesn't have to be this value. This is known as the keyword column, and there actually are some additional keywords here. It's not just wait all the time, and we'll get to talk about the different ones we can get. This really just tells the init process how this particular line is supposed to be handled. So right now, as we can see here, the example just says wait for all entries. We'll get to see what that means and the alternative values in a minute. And the last value here at the very end, all these ones, this is ultimately the command. It's basically the command that the init process should run when this line happens to be selected. So one of the things that we have to focus in on are these different values that we can have for the action. In this case here, we just see wait. What are the values we have available to us? But let's actually talk about it. So the very first value I want to talk to you about is the init default value. And this is all one word, init default. Now all this does, it ultimately specifies the default run level for the system. So if you specify init default, like I say, that will be the default run value. So let's maybe say we have an ID value here. So we have our ID column, we have our run level column, and our action column. If I happen to maybe give the ID, I don't know, L2, whatever it may be, and then the run level of 3, and then I specified the action was the keyword init default here. When the init process goes to read this particular file, it's going to see the init default action keyword associated with run level 3, and the default run level, whenever the system boots, it's going to run at run level 3. Okay, so init default, very, very important. The next value we have is sys init. And what this means is that any commands that we happen to specify after the sys init keywords, those commands are going to be executed as soon as the system boots. So it doesn't matter what run level we happen to go into, these commands are going to be executed straight away before anything else. Now the next one is one we happen to see quite a bit in our example. That happens to be the wait action. What this is going to instruct init to do, it's going to tell init to simply wait, and it's going to wait for the commands that have been specified after this keyword to fully complete. Now some of these commands are going to be scripts that maybe take, I don't know, 10 seconds. When we have this wait keyword, we are ultimately ensuring the init process is going to allow these scripts to fully complete before any other commands are executed. This is really all about system stability to make sure the startup happens in a correct, orderly fashion. Now another value happens to be Control-Alt-Del. You may be familiar with this combination. Now what this action does, it's designed to trap the keyboard combination that we use when we type Control-Alt-Delete. The reality is that pressing this combination can result in some type of file system corruption, and instead we want to invoke a more graceful shutdown. So really we want to trap these keys and replace it with the shutdown command or something like I say, which would result in a more stable and graceful shutdown. You do not want to be causing any type of system outage due to file system corruption. Now the other action we have is the power fail action. Now what this is actually sent from, it's sent from the UPS, no, not the mail service. It is the uninterruptible power supply. And this is sent from the UPS when the UPS is about to run out of power. So if you happen to receive this power fail signal, it means that the power supply is coming dangerously close to emptying, so you want to shut down your operating system to prevent some type of instability if the power cuts and the system just crashes. We have two more to get to. The next one is power OK wait, and again this is all one word, power OK wait. This again relates back to our uninterruptible power supply or UPS. So let's say that the UPS happens to send that power fail signal we just talked about. However, let's then say the UPS begins to receive power once again. So power has been returned. The way we can signal this, that everything is indeed okay, is by sending this power OK wait action. So when this power resumes, this signal itself here is going to be sent to the init process. So when we are starting up, init is fully aware of what is actually happening. Now the last one is the respawn action. Now this might sound like something out of a video game, maybe Halo or something. Now this relates to a command called min-getty. Now what this actually does, it allows for command line logins, okay? So if a user happens to log off, the process has to restart so that another user can log on again. It tells the init process to start the min-getty operation at run levels 2, 3, 4, and 5 so that users can indeed log in. Now like I say, run level 0 is a shutdown, so we don't need to log in. Run level 6 is also for rebooting, whereas run level 1, that is only going to allow access to the root user. So this idea of being able to log out and have to present again another login for another user to go on, this doesn't actually make sense in the context of run level 1, hence why the respawn action is only available at run levels 2, 3, 4, and 5. So like I say, if we happen to see things like the ID and the run level, maybe say run level 5 and init default, we know straight away that the default run level is going to be run level 5. Whereas if we see something like say an ID and then the sysinit action, in fact let me just spell this correctly, and then maybe we get a value such as etc/rc.d, which is the rc.d directory, we'll talk about that very shortly, and then rc.sysinit, and I'm running out of space there, apologies. What this ultimately is right here, this is some setup scripts. And because we are using the sysinit action, the commands set out in this setup script will be executed when the system boots, regardless of any type of run level. So really we can have a whole bunch of different combinations with respect to what we see within the inittab file. But ultimately the inittab file is all about being able to set up our system in a secure and reliable way, so that if scripts have to run at a particular time, they are able to run at a particular time and be free to complete, whilst we could take other actions such as preventing Control-Alt-Deletes from inadvertently destabilizing and corrupting our file system, as well as controlling things like the default run level that we want to initially boot into. All of this and more can be controlled directly from the inittab file, which is, like I say, what the init process initially consults. Now, we happen to mention this concept of scripts, the idea that when we boot up, we want to run some particular setup scripts which are going to execute particular commands and run particular processes. What exactly are those scripts? Well, to help us make sense of what we have just saw right here, we're going to be talking about this in the very next nuggets. I hope this has been informative for you, and I'd like to thank you for viewing.